Hi everyone. Today let's talk about session 6.4, volumes by shells. Big idea. Another way to calculate the volume of a solid of evolution is to break it into series of thin, wadded, nested cylindrical shells. Big skills, you should be able to calculate a volume of evolution using the shell method. Let S be the solid obtained by rotating about the y-axis, the region bounded by the graph y equals f of x, where f is continuous and positive. And so this is our region, okay? And we want to rotate this regions about the y-axis, okay? So then we get a solid like this. Does it look like a pudding? Okay, and the volume of the solids in the figure above obtained by rotating about the y-axis. So last sessions we talked about the shell method, the washer method, and this method. We cut it like this, right? So we get a slice either at this or annulus. But in this class, we cut it into thin layers, okay? And each shell. In each shell, you can see this is our rectangle, okay? So last time we cut the rectangle, we cut it perpendicular to the axis of rotation. Today, when we use shell method, we actually cut it parallel to the axis of rotation. You can see this is the rectangle, and when we rotate, let's look at the end point. When you rotate, so you see this, it will give us a circle. This will give us another circle, but those two circles are the same size, and we actually get cylinder layer shells, right? And if we cut it and open it up, so when we have a scissor and we cut here and open it up, we actually get like a rectangle. And what is the width? So the width is change of x, so this is like dx, change of x. And the height here is y is f of x, right? And how about so if we call this is h and we call this is r, and this guy is the same as, this guy, the bottom, the length is actually the circumference of a circle, so that is 2 pi r. Okay, so that's why we have the volume is sum of the volume of each shell, the volume of the shell, and each shell, the volume is like a rectangular solid, and we have 2 by r is the length, h is the height, and the width is the x. So that's why this is our formula. So far so good, everybody. Okay, so let's continue. So example 1, find the volume of the solids obtained by rotating about the y-axis, the region bounded by this function, and the y-axis in the first quadrant. Okay, so let's draw a picture. What is this guy? Let's see. We have some common factor x squared. After we factor out x squared, we have 2 minus x, right? And so that will give us the x-intercept is 0 and 2. Okay, and you can actually see, well, when we plug in 3, let's see what happened. When we plug in 3, 3 squared 9, 2 times 9, 18, 3 cubed 27, so negative 9. So it's gonna be a negative number, okay? So negative number. It's raining right now. And so in this region we can plug in 1, then 2 minus 1 is 1. So it is like this. Okay, and then this guy, when we plug in -1 squared is 1, so 2, but -1 cubed is -1, so -1 become 1, so 2 plus 1 is actually 3. So this is the picture. It roughly looks like this. Okay, and we want to find the volume of the solid obtained by rotating about the y-axis, and so the region is bounded by this guy and the x-axis. So this is the region. We want to rotate about the y-axis. Okay, so and in this example, we must cut it vertically. Why? Think about it. If you cut it horizontally, oh, the upper curve is this function, the lower curve is still this function, and because it's the horizontal distance, you want to solve x in terms of y. Are you able to solve for x in terms of y in this example? No way. So that's why these examples we have to use the shell method. Okay, so first steps, we sketch the picture, we figure out the rotation axis. Second steps, we decide to cut it vertically or horizontally. So in this case, we cut it vertically and we get dx. So we're gonna expect to have an integral with respect to x. And then the third step, we draw what happened to the end points if we rotate about this rotation axis. We get two circles, but is this actually a cylinder? So if you get one big circle, one small circle, that is the washer method. But if you get two same size circle and this is actually a cylinder, then we know it's shell method. So the picture, okay, so follow my steps. The picture will tell you what to do. If you get one circle, that is the disc method. If you get two circles, that is the washer method. But if you get a cylinder, that is the shell method. Well, cylinder, then you talk about the radius and height. So always remember, given any functions, vertical distance is the y, horizontal distance is the r. So in this case, okay, for this point on the graph, my r is actually my x. My h is actually my y. And because right now we want to have an integral with respect to x. So x, keep the x. For the y, change it in terms of x. See? So that's very important to figure out in the second steps whether you have a dx or a dy. And finally, my x goes from 0 to 2, and then formula 2 pi r h dx. What is r? R is x. What is h? 2x squared minus x cubed dx. So how do we solve this integral? Remember, we don't have product rule, and in this case, u substitution also doesn't work, okay, because the du does not match. So, but it's okay, we can distribute it, and we just use the power rule to integrate. So, this is x to the 4th over 4. This is x to the 5th over 5. Evaluate from 0 to 2. Okay, so let's plug in 2. When we plug in 2, 2 to the 4th is 16. 16 divided by 4 is 4. 4 times 2 is 8. And then, 2 to the 5th, 32. When we plug in 0, it's all 0. Okay, do you know what is 8? 8 is actually 40 over 5, right? 40 minus 32 is 8. 2 times 8, 16 pi over 5. So this is our answer. So far, so good, everybody? So we follow the same steps. Step 1, you're gonna sketch the graph and then find the rotation axis, find the intersection points if you have two graphs. And then second step, you want to decide how you will cut it. If you cut it perpendicular to the axis of rotation, you're going to expect to use disk method or washer method. If you cut it parallel to the axis of rotation, you're going to expect to have shell method. So figure out is dx or dy, okay? And the third steps, draw what happened to the endpoint of the thin rectangle and see what do you get. If you get one circle, this method. If you get two circles but one big, one small, that is washer method. If you get a cylinder, that is shell method. For shell method, you need to figure out the R and H. Then look at your picture. What is your R? What is your H? And then just plug into the formula and evaluate the integral. Okay. So far, so good. Let's do more examples. Okay, so this one. What is the volume of the solid form when the region bounded by this curve over 1 and 2 is revolved about the y-axis? Okay. We don't know what this function look like, but it's okay. We just plug in 1. So if we plug in 1, well, 2e cubed minus 5. Well, this is a big number, but I know it's gonna be a positive number. So, okay, when we plug in 2 is 2e to 6 over 2 minus 10 is even a bigger number. You can plug this in your calculator and see how big it is. But anyway, as long as I know it's gonna be a positive number, so my graph look like this. Okay, I don't need to know exactly what this number are. I just need to know their positive number. Then I can draw my picture. Okay, so I want to rotate about the y-axis. So this is my y-axis. Next, how do we cut it? Okay, so by the way, there's no way you can cut it. So because if you cut it this way, the upper curve is this, the lower curve is this. Are you able to solve for x in terms of y? Not really, right? So that's why, okay. That's why we cannot cut it horizontally. So we must cut it vertically. Then this is the x. So draw what happened to the endpoint when we rotate. We get a cylinder, so we have R and H. So R in this case is the what? The x, right? Remember, horizontal distance is the x, vertical distance is the y. And because we have dx, so we want to express the y in terms of x. So, which is 2e to the 3x over x minus 5x. So, my volume equals integral, x goes from 1 to 2 pi r, r is x, h is 2e to the 3x over x minus 5x dx. Okay, how do we integrate this? Pull out the 2 pi, and then we can distribute, right? When we distribute, we have 2e to the 3x. Here we have 5x squared dx. So far, so good, everybody. And what happened? So right now, we see we have 2 pi, and integral of this guy is 2 over 3 e to the 3x minus 5 over 3x cubed. Evaluate from 1 to 2. So we plug in 2. So it get e to the 6 minus 5 over 3. 2 cubed is 8. Minus, we plug in 1. So 2 over 3 e to the 3 minus 5 over 3. Wow. This is big. I allowed you to use your calculator. Okay, let me find my calculator and plug this guy in. So I have 2 pi times 2 over 3 e to the 6 minus 5 times 8 is 40, 40 over 3, minus 2 over 3 e to the 3 minus, oh, I also break the parentheses, but you can feel free to type your parentheses in it. And then 5 over 3. Okay, and I got 1532.44. Okay, so please help me to check my work. Do you have the same answer? Yes, so sometimes I might make mistake. So please feel free to help me to check my work. If you find my mistake, please let me know. So yes, that's why I always tell my students, please try your answers again and again in your exams after you're done, okay? Because sometimes even I make mistakes when I write down the solution. So it's very important to check our work, okay? We learn from our mistakes, so don't be afraid of making mistakes. We learn from them, okay? They are happy accidents. I like Bob Ross. Okay, so example 3. Find the volume of the solids obtained by rotating about the line x equals 6, the region bounded by this 2. Ooh, okay. So in this problem, remember if the rotation axis is not x or y axis, you just need to set it up, the integral. Do not need to evaluate. Okay, so let's see. 2 square root of x minus 1 and y equals x minus 1. We actually draw this before, right? We draw the line first, and it passed through this, right? And then to draw the square roots, we know square roots look like this. And we want to think about, okay, what is the smallest x we can get integer? Well, smallest x is 1, right? So we get this point. And when we have x equals to 2, so then we have 2 here. When x equals 5, we actually get 4. Oops, where's 4? Oh, here, 4. So we actually get another intersection point. Okay, so it looks like this. Okay, so we want to rotate about the line x equals 6. Oh, 6 is right here. So we want to rotate about this. Okay, how do we cut it? So in this way, let's use shell method so we can cut it parallel to the axis of rotation. So that's why this is the x. And what happened to the endpoints? We draw it so we get a cylinder, right? It's ugly, but it's a cylinder. With this is my R and this is my H. What is R? Well, okay. Remember any function. This is x, this is the y. So, you can see this is the whole thing. This whole thing is 6. And then from here to here is x. So you have the whole thing that is 6. From here to here, that's x. This is the r. So what's the r? 6 minus x. Right? And what is the h now? Well, h is the difference between two curves. So that's the vertical distance. So it's the y of the curve minus the y of the line. But y of the curve is 2 square roots of x minus 1. The line is x minus 1. But don't forget the parentheses, okay? So this is 2 square roots of x minus 1 minus x plus 1. Okay, finally, my x goes from 1 to 5, and then 2 pi r. R is 6 minus x. H is 2 square roots of x minus 1 minus x plus 1 dx. And that's it. That's it for the setup. So far, so good, everybody. So, I want to assign more exercise. So, try this at home. So, exercise at home. Try to rotate about the line x equals to -2. Okay, so rotate about the line x equals to -2 and see what happens. Probably I can give you some idea. Okay, so -2 here, right? So your circle's gonna look like that, right? Your h will be the same, but your r is gonna be from here to here. Well, this guy is x, this guy is 2, so your r will be x plus 2. So your h will be the same, but just you're gonna change your r. Your r is now x plus 2, but your h is still the same. Okay, so you just replace this guy by x plus 2. Okay, that is for when we rotate about the line x equals -2. So far so good, everybody? Alright, let's continue. Example 3, find the volume of the solid obtained by rotating about the line y equals -1 and the region bounded by these two functions. And we just need to set it up. Do not evaluate. Oh, by the way, I forgot to show you our the GeoGebra. Okay, so the first example. Okay, you'll see now here. This is our example. You can show the surface and we can show the cylinder. And this is, oops, let me see. How do I change it? Okay. You see? This is what happened. This is what the cylinder looked like. Can you imagine? Okay, how about the third example we just did? You see, here we have the cylinder and the surface, the solid. Okay, you can see. So play with these pictures. Okay, so play with them and then you can see our solids and the cylinders. I hope this GeoGebra projects can help you to increase your understanding, visualize the solids. Okay, let's continue. So example 3, we want to find the, okay, so let's first sketch them. So let's see. So y equals x, that's easy, that's the line. Okay, next. Well, next is gonna be a parabola, but it's gonna be open to the right. Let's plot some points. If x equals, so if y equals to 2, x is 0, so 2, 0. Okay, if y equals to 1, you get x is 1. Oh, you see, we get this intersection point automatically. And y equals 3, x is 1. Y equals 4. 4 minus 2, 2 squared. It's 4. Oh, do you see this intersection point? We get another intersection point. So this is the picture. Okay, and we get the intersection point 4, 4 and 1, 1. So far so good? Okay, next we want to rotate about the line y equals -1. So this is -1. We want to rotate about this axis. Now let's draw it. Okay, so how do we cut it? By the way, we can't cut it like this because it would be so complicated because on the left, the upper curve is the curve, the lower curve is also the curve, but on this piece, the upper curve is the curve, the lower curve is the line. So we don't want to separate into so many subcases. I mean, two subintegrals, and that's more complicated. So let's color it this way. Then we have dy. Okay, so you can see we're going to expect to have an integral with respect to y. What happened to the endpoints when we rotate about the axis? Well, this is going to be the center, and we get a circle. This is the center. We get another circle, and this is a cylinder. And cylinder radius of the base circle is r, and the height is h. Okay, so what is r in this case? Well, remember, any curve, vertical distance is y, horizontal distance is x. So from here to here, that is my y. From here to here, that's the 1. So my r is actually y plus 1. Okay, so that is my r. How about my h? Well, my h is gonna be the difference between them, but those are the horizontal distance. So horizontal distance, we have the x on the, so we use the bigger one, so which is the function on the right. This is the x on the line minus the x on the curve. Well, the x on the line is, what is that? Okay, because x equals y, so that's y. But x on the curve, that is y minus 2 squared. Okay, finally, my y goes from 1 to 4. And then 2 pi r is y plus 1, h is y minus 2 squared, dy. So this is the setup. So far, so good, everybody. So here we just need to set up the integral, and we do not need to evaluate. Okay. All right, so let's continue. Okay, so example 4. Let R be the region in the first quadrant bounded by the graph of y equals square root of x minus 1 and the line y equals 2. Find the volume of the solids generated when R is revolved about the x-axis. Find the volume of the solid generated when R is... Okay, so part A, because it's revolved about the x-axis, we actually need to solve the integral. But for part B, just set up the integral. Do not evaluate. Okay, so let's draw the picture. Y equals 2. So 2 is here. X equals... So y equals square root of x minus 2. So what's the smallest number for x? Okay, the small number is 2, right? So 2 is 0, and then f3 is gonna be 1, and then when x is 6, we get square root of 4 is 2. So you see 6 right here, and we actually find the other intersection points. Okay, and we want to look for the regions. So this is the region in the first quadrant bounded by the graph and the line. Part A, we want to find the volume of solid generated when R is revolved about the x-axis. So the x-axis is right here. So there are two ways you can cut it. One way, if you cut it vertically, but you can see if you cut it vertically, if you here, then the upper function is the line, lower function is the curve. If you cut it here, the upper function and lower function, they're both the lines. So but you need to separate into two integrals. So in order to not to separate into two integrals, we can cut it horizontally. Then the upper curve is always the curve, the lower curve is the y-axis. And then we draw what happened to the endpoints when we rotate. We get a cylinder. This is the R. This is the H. And R, in this case, they're the vertical distance. That's the Y. And my H is the horizontal distance. That is the X. So far, so good, everybody. Because here we have dy, so we want to express the x in terms of y. Oh, so square both sides and add 2. This is how we solve for x. So far, so good, everybody. So x is y squared plus 2. And then the volume, my y goes from 0 to 2. 2 pi r, r is y, h is y squared plus 2 dy. 2 pi, move it out. And then we can distribute it, right? Here you can also use u substitution, but I think distribute and use the power rule is easier for me. Okay. And then integral y to the 4 over 4. This is y squared, right? 0 to 2. We plug in 2 first. 2 to the 4th, 16. 16 divided by 4 is 4. 2 squared, 4. And then minus 0. Oh, I get the answer is just 8 times 2, 16 pi. That is part A. So far, so good, everybody. So for part B, let me change a different color. Part B, we just need to set up the integral, do not evaluate. Okay, we want to rotate about the line. Y equals -2. Okay, so now what happened? Do you see, we're gonna have a bigger circle. So my h is still the same. Do you see the h still the same? But my r is y plus 2, right? This is y, and then you add 2. So this is my r. Okay, and so my v is 0 to 2, 2 pi. My r is y plus 2. My h is y squared plus 2 dy. And we just need to set up, and that's it. So far, so good, everybody. Okay, I want to ask you one more question. So, what if you want to rotate about okay, let me change a different color. So blue. Okay, let's make it C. Let's say we want to rotate about the line x equals -1. Or what do we do in this case? So if in this case, so if we want to rotate about this line, what do? We will still cut it this way. This is dy, but now we're gonna have 2 circles. So that is the washer method. You're gonna have the big R and the small r. You see your big R is gonna be on the curve. So that's the x on the curve plus 1. Okay. And what is that? X on the curve is y squared plus 2 plus 1. So it's y squared plus 3. And what's your small r? Your small r is 1. Can you see from the picture? Your small r here is just 1. And so we're using washer method. So volume is integral. My y goes from 0 to 2, and then pi of big R squared minus small r squared. 1 squared is just 1 dy. So this is the setup for it. So far, so good, everybody. So you see, that's why I asked you to follow my steps. The picture will tell you what method to use. If you see a cylinder, that is the shell method. You care about small r and the h. And then when you see two circle, one big, one small, that is the washer method. Then what do you care? You care about the big R and the small r. And you can see from the picture what is your big R, what is your small r. So far so good, everybody. And so we still have, let me show you. Okay, this is the example. Okay, so this is the example we just did, and you can see this is the solids it generates. This is the cylinder. Can you see this solid? So here we're rotating about the line y equals -2. So far so good, everybody. So I hope you can play around with those GeoGebra projects. You can do the project and earn 0.5% extra credits. Okay, next. I'm gonna ask you to revisit our 6.3. So actually, sometimes many examples we can use both way to solve it. Okay, it depends on how we cut it. So I want to revisit example 5 and example 7 of our previous sessions. So I already copied down those examples here. So last time we used disk method to solve. Okay, so today I want to show you how we solve it using the shell method. Okay, so we still have the same picture, and we want to rotate about this. But last time we cut it perpendicular to the axis of rotation, but today we're going to cut it parallel to the axis of rotation. And then what happened to the end points? We rotate and get a cylinder. So we have small r and h. What is small r? That is the horizontal distance. What's horizontal distance? X. And what's h? Well, is h the y? Be careful. H is actually, so the total thing is 8, and your y is from the point on the curve to the x-axis. So this is the y, and then your h is actually 8 minus y. And because we're getting dx, so this is the integral with respect to x. So change the y in terms of x. See, this is my r, this is my h, and my v is integral. My x goes from 0 to 2 pi r, r is x, h is 8 minus x cubed dx. Alright, so it's better to distribute it. So 8x minus x to the 4th dx. And integral of that, 8 divided by 2 is 4x squared, and x to the 5th over 5. Evaluate from 0 to 2. And we plug in 2 squared 4. 4 times 4 is 16. 2 to the 5th, 32 over 5, right? And when we plug in 0 is 0. So 5 times 16 is actually 80. What's 80 minus 32? Well, that is 48. 2 times 48 is 96 pi over 5. Do you see we get the same answer? And that's always the case. Because it's the same solids, right? We're asking the volume. So that's why some problems, we can cut it differently. We can cut it into slides, or we can cut it into shells. So you can compare both ways and pick the one you think is easier for you. But for some problem, you can only use one way, because maybe you're not able to solve x in terms of y, so you have to cut it that way. Okay, but these two examples, we can actually cut it in both ways. So this example 7, what we did is we'll use washer method. So today, we're going to see what happens if we cut it into shells. So, okay, so let me draw the picture again. Okay. So here, and we want to rotate about this guy. So if we're going to cut into shell, we're going to cut it vertically. So we're going to have a cylinder. This is R, this is the H. So R is the horizontal distance. That is the X. H is the difference between the vertical distance, okay? The difference between the vertical distance of them. So that's the Y of the curve minus the Y on the line. Okay, Y of the curve, because we have dx, we want to express everything in terms of x. Y on the curve is x to the cube roots. Okay, x to the 1/3. And Y on the line is x over 4. Then my volume is, my x goes from 0 to 8. 2 pi r, r is x, h, x to the 1/3 minus x over 4 dx. 2 pi, move it out, distribute it. So x to the 4 over 3 minus x squared over 4. We integrate. Well, x to the, we add 1 to it, 7/3 over 7 times 3. X to the 3, 4 times 3, 12. Evaluate from 0 to 8. Okay, so 8, cube roots of 8 is 2. 2 to the 7 is 2 to the 5th, 32, 2 to the 6th, 64, 2 to the 7, 128. And then 7 minus 8 cube. Okay, so 8 cube, what is that? Well, 8 squared is 64, but there's another 8 you can cancel with the 12. We can cancel the 4, so we have 2 times 64 is also 128, and the bottom we have the 3. So far, so good, everybody. Can you see we can factor out 128 and 2 pi? And let's see. So we have the common, and then what's left is just 3 over 7 minus 1 over 3. And let's see. That's 21. 3 times 3, 9. Minus 7. Oh, that is 2, right? So 2 times 2 is 4. 4 times 128 is 512. Oh, do you see we have the same answer? And that's always the case. So from now on, when you find the volume of some solids, I would suggest you to think, which method, how do you want to cut it? Vertically or horizontally? What method do you want to use? Which method is easier? So think before continue. Okay, so and sometimes if you get stuck in one side, try the other way. Okay, there are so many ways we can go to the same city. So and that's it for this session 6.4. Okay, so have a nice day. Bye.